Okay, welcome to Physics 114. This will be part 2 of Lab 2, and this will be the yellow lab. So what we're going to be doing is bypassing a bunch of stuff that we don't have to read, and then we'll be going to, okay, so you remember the blue lab? We did the walking away slowly, walking away fast, walking towards slowly, walking towards fast. We're going to do the same thing, but this time we're going to use velocity time graphs instead of position time graphs. So let's go ahead and do that. Go ahead. Okay, so if we look at the y-axis here, we can see that it's labeled velocity instead of position, and so that's a good sign. But we're going to be using the same stuff. We're going to be using the motion detector. We're going to be using the plastic boards. Okay. Okay, so go ahead and start it. And when I walk away slowly, okay, so the thing to notice is for like the first 2/5 of a second, it's showing that I am not going anywhere. And then for the next 3/5 of a second, it shows me speeding up. And then things level off, but notice how it goes up and down. You can see my steps. They say a Shaolin monk can walk through walls, but I would challenge one to make a horizontal graph on a velocity time graph. Okay. Okay, so that's part A of the first section here. Now let's go to part B. I'm going to now walk away. And when you're answering the questions about this, kind of ignore the fluctuations up and down. Just look at the kind of horizontal trend as opposed to the fluctuations. Okay, so go ahead and okay. Okay, so I walked really quickly, so quickly that it went out of the screen. So let's go ahead and hit A there, and that adjusts. And so I went faster than a meter per second, and I did not go with a very constant speed. Let's try this again, just because I think my speed was not very constant. That's much better, up to the point where I tripped on a chair. Okay, so, if you squint a little bit, you can kind of say that, okay, this was pretty much horizontal. Okay, so let's reestablish that graph. Let's go ahead and say, okay, I'm going to say File, open, velocity graphs, open, and no, I don't want to save any of this. Okay. Alright, so now what I've done is I've reestablished the scale of the graph so that I can do so we can properly assess the next part. Alright, so I'm going to start far away and move toward the motion detector quickly. Slowly, I should say. Yeah, I'm going to move toward it slowly. Oh, well, let's see. Yeah, okay. Yeah, that'll do. Okay, so I spent, like 1.4 seconds here doing nothing, and then I finally got around to getting moving, and so now we have a graph of the of my motion. Okay, so now I'm going to do it quickly, maybe not as quickly this time. Okay, ready? Okay, so this time I tried to keep it from going off the graph, but okay, you can see here I was speeding up, and here I was maintaining, or trying to maintain, a steady but quick motion. Okay, so so you can use that data to answer questions 2.1 and 2.2. And so then I'm going to do the same thing that we did before, you know, the thing of going back slowly, stopping, going back quickly. So for that, okay, so ask for a prediction, you know, well, once again, you know, you might want to pause the video and make a prediction as to what that motion would do with a velocity time graph this time, and we'll see what it actually does. Okay. All right. I assume that you're back from making your prediction. So let's see. I'm going to start about here, and I'll go ahead and start it. Oh, wait a minute. There's a different. I think there's a. I think there's a different file here. Maybe there isn't. Okay, so what I'm going to do is I'm going to go in and hit the clock icon and increase my time to 15. There we go. Okay, so let's see. Okay, so back slowly for 5 seconds, stop for 5 seconds, forward for quickly for 5 seconds. So let's do this. Okay, so this time I think I can rationalize auto-adjusting my data here. Oops, no, too many spikes. Undo. Okay, so, well, but what we can see is that while I was walking slowly, okay, I had this this fairly constant velocity. Here's what things looked like when I was stopped, and then here's here's what my data did when I was walking forward quickly. And truth to tell, in this lab, we're not worrying, you know, or the last lab, we're not really worried about the quantities. We're, you know, taking qualitative assessments of these things, and so I think we're okay. All right, so the next part, we're looking at arrows and things. And a couple things. When you answer that question, make sure you include in your arrows both making sure the directions are right and making sure that the lengths of the shafts of the arrows are right. Okay? Be careful with that. And make sure that any difference in the lengths of the shafts that you make are clear. Okay, and it asks about standing still. Okay, so when you have, you know, when you go fast, you should have a long shaft. When you go slow, you should have a short shaft. Which, standing still, you might think it's nothing, but I would ask you this question. What geometric object has no length? Contemplate that, and that's the answer to the second part of that question. Okay. So now we're going to do graph matching. So let's go into that file. open. And velocity match. That's what we want. Okay. All right. So now we've got this graph here that I'm going to try and match, and we'll see if I succeed. Okay, so we can see that, okay, I need to stand still right here, and then I need to increase really quickly. And then it stops again. So let me do that. Okay, so go ahead and start it. Oh, well, that didn't work very well, did it? Because notice that my speed went way too high, and it came down again when I wanted it to, kind of level off here. So, what's going on there? Well, okay, this is a velocity graph. So this needs to be my velocity. And so if I stop, my velocity goes to 0. So let's try this again, keeping that in mind. Went the wrong way. Let's try this again. Okay. There we go. Okay, well, yeah, there's a problem. Notice that by starting really quickly, my velocity spiked. So yeah, by keeping moving, it meant that it didn't go to 0. But I don't want that spike. So apparently, I don't want to go really quickly at first. So let me try doing this where my transition is not so great. Oh, well, okay. The first part of the graph was somewhat better. I was a little late there on the uptake, but I managed to keep it pretty close to the line if you squint a bit. And then I stopped. Okay, that's good. And then I went back for a while, but then I ran into the motion detector. And here's the thing. My forward motion is going to be the same, is going to have the same speed as my backward motion, but the backward motion has a longer time, and that means that I'm going for a longer distance. So that's why I ran into the motion detector. My distance away was smaller than my distance toward had to be. So then the puzzle is, how do I compensate for that? And this is one of the disadvantages of the fact that you're not actually doing this lab, is you'd have to figure that out. But I'm doing the lab, so I'm going to tell you the answer, and that is I start further away. So go ahead and start it. Okay, so my did better this time. My motion graph is reasonably close to what was required of me. Then I stopped, and then I started moving back toward, and I was able to cover the entire distance without running into the motion detector because I had enough distance in reserve, as it were. And also notice I started further away, and yet my velocity graph still says 0 here. Okay? The velocity graph doesn't care about where I am. It just cares about how fast I'm moving and which way I'm going, away from the motion detector or towards the motion detector. So, so that is something to keep in mind when you answer the questions for the lab. I think that that's about it. Okay, have a good time answering the questions. Get the lab into me, and see you next time.